Hey guys, and welcome back to the only channel bringing you BMET tips and tricks to make it through the schoolhouse. It's shocking to me that you've almost completed course 101. Today in class we discussed AC power, then moved into low pass filters and high pass filters, and we wrapped up the day with band stop and band pass filters. Why don't we get going here? If you remember from day 7, power is the rate at which work is accomplished in a circuit. Power is generated when AC flows through resistance or reactance. There are 3 types of power in AC circuits. Real power is the power dissipated by only the resistor. Reactive power is dissipated by only the inductor or capacitor, and apparent power is the combination of real and reactive. Easy enough, right? Now for filters. Filters allow certain frequencies to pass and certain frequencies to be attenuated or blocked. Low pass filters will pass the low frequency and attenuate the high frequencies. What the filter does is right in the name. Low pass is low, high pass is high. Frequency cutoff, or FC, is the point or frequency that determines which frequencies pass to the output and which frequencies attenuate. Remember, attenuate is just a fancy word for blocking. At FC, XC and XL values equal the resistance value. At FC, the output amplitude is equal to 70.7% of the input amplitude. For example, say we have a 100 volt signal coming in. At FC, we would see 70.7 volts on the output, or 70.7% of the input. How am I going to tell the different types of filters apart? Well, I've got some surefire ways for you. The first filter we're going to take a look at is an RC low pass filter. But how do I know it's a low pass filter? When a capacitor is in a filter circuit, the position of the cap will indicate what type of filter it is. In this case, the capacitor in relation to the resistor is low and in parallel with the resistor. I like to remember it as low cap, low pass. Now if the capacitor and resistor swapped places, it would be a high pass filter. High cap, high pass. Now that we've identified what type of filter it is, let's determine whether it's effective or not. The formula for calculating FC is on your formula sheet. 1 over 2 pi R times C. This will give us the frequency cutoff for our filter. Now to plug it in. 6.28 times 2K times 6.6 nano x minus 1 equals gives you 12.06 kilohertz. Now do you remember how we showed you to check if it's effective or not? Is 12 hertz lower than 12 kilohertz? The answer is yes. And when the answer is yes, it means that the output of the filter is effective. Now to identify an RL low pass filter. Do the 2 components in the circuit remind you of anything? I would say that the resistor looks like mountains and that the inductor looks like hills. So if the hills are over the mountains, it's a low pass filter. If the mountains are over the hills, it's a high pass filter. Now to determine if this RL low pass filter is effective. The formula for calculating FC is R divided by 2 pi times L. So go ahead and punch in the values and use the trick to tell me if it's effective or not. Is 22 kHz lower than 12 kHz? No. This means the output of our filter is not effective. Let's try the same thing for the next 2. Remember, the position of the capacitor determines what type of filter it is. Since it's high, it's a high pass. Now to calculate the FC. Well, what do you know? It's the same values as the RC low pass. So let's skip ahead to seeing if it's effective or not. 12 Hz is not higher than 12.06 kHz. Therefore, it is non-effective. Now for the RL high pass. Mountain over hills, right? Is 100 kHz higher than 12.01 kHz? Yes. Therefore, the output of the filter is effective. That's it guys, we covered AC power and filter fundamentals. If you liked the video, don't forget to hit that like button and subscribe for more BMET tips and tricks. And as always, stay classy and keep your head up.